Section 2.7 deals with graphing polynomials. Now, a lot of this we'll do on the calculator, but there are times when your calculator will show you a graph and it's not entirely accurate just because of the way the pixels work on the screen and things like that. So you need to be able to graph them by hand as well. So, polynomials. You know what a polynomial is, and we're going to talk about their pictures. The things you need to know about their pictures is we've talked about domain. Remember, that's all the x values. For polynomials, the domain is all real numbers for every polynomial. That's what this sign means, for every. Now, the range is sometimes limited, but the domain, the x values, is all real numbers for every polynomial. Polynomials are always continuous. Basically what that means is you don't have to pick your pencil up to ever draw your graph. There's no jumps, no gaps, no vertical asymptotes, no holes, nothing like that in a polynomial. Now, polynomials, we've got two separate cases. We've got polynomials that are even degree. Remember, that means that the highest exponent is an even number. What happens with the picture for that one is we end up with both tails up or down. They're in the same direction. Now, what do I mean by that? Well, we know polynomials, or we know quadratics, parabola. That's an even degree. So we have both tails up. See, both pointing up. Or if we have negative x squared, we have both tails pointing down. Now, if you have a 4th degree or a 6th degree, 8th degree, no matter what happens in the middle, your tails are going to be in the same direction, no matter what, with an even degree polynomial. Now, what happens if you have an odd degree? An odd degree polynomial, your tails are opposite. So, for example, y equals x cubed. If you graph that, starts out negative and ends up positive. Or if you have y equals negative x cubed, then it's the other way around. But the tails are in opposite directions. No matter what happens in the middle, if you have a 3rd degree, a 5th degree, 7th, 11th, 21st degree, your tails are going to be in opposite directions. So that's something you need to look at when you see the equation. When you look at an equation of a polynomial, you need to first decide for yourself, what's the degree? What is my picture going to look like? Is it going to have both tails in the same direction or tails in opposite direction? Start there so that you know if you're getting the right picture from your calculator. So, some steps to graph this by hand. And yes, you do need to be able to graph this by hand. So the first step is to find the zeros. We've talked about ways to do that. With quadratics, it's pretty easy. When it gets bigger, you have to use synthetic division. Remember, use those possible rational roots. And sometimes we have multiplicity. And one thing about multiplicity is it gives you a 0 on the x-axis, but it happens more than one time. So what does that mean for the picture? Well, if you have an even multiplicity, like if you have a 0 that happens twice, then that means at that place it bounces off the x-axis. So for example, if you have the parabola that it has an even multiplicity, say at -1, then it's going to look like that. It doesn't actually cross there, it just touches there and bounces back off. Now, if it has an odd multiplicity, like you have if you have a 0 that happens 3 times, then it still crosses the x-axis. So first you find your zeros using synthetic division, factoring, quadratic formula, all those kind of things until you have all your zeros. Now remember that imaginary zeros, you're not going to graph those because we're graphing things in the real plane right now. So we have our zeros, you plot those, and then you figure out the tails. Consider the tails based on the degree. And also you can look at the leading coefficient sign, because that'll tell you, for example, if it's even, if the leading coefficient is positive, then they're up. If it's negative, then they're down. And with the odds, if it's positive, the leading coefficient is positive, then the left one is down and the right one is up. And if the leading coefficient is negative for an odd one, then the left one is up and the right one is down. So you can look at the pictures that we just did for x cubed to see that. So we figure out where the tails are going, and then we think about the symmetry. So for this we have to look at all the terms, not just the leading term, just the degree term. So we have symmetry across the y-axis if all of the terms are even degree. So this is line symmetry. And then we have it across the origin if all the terms are odd degree. And that's point symmetry. Now, what does that really mean? If you've heard of even functions and odd functions, we've talked a little bit about that. But what this means is this is an even function. It means that if you replace x with negative x, you're going to still get the same function. And this one is an odd function, which means if you replace x with negative x, then you're going to get every sign changed. So you look for that symmetry to help you know. Like with a parabola, if you're looking at x squared, then if you get one side of it, you know that you've got the other side. You just have to make a mirror image because we know that that has the line symmetry across the axis of symmetry there through the vertex. Sorry. All right. So we find our zeros. Think about the tails. Think about the symmetry. And then we're going to find our y-intercept, which is just plug in x equals 0, which is usually really simple the way the polynomials are written. And then you can get some other points to help. And then finally, you connect the dots in a smooth, continuous curve. All right, so 5 steps to graphing by hand. So we're going to do one example and go through these steps so that we can make sure we do this. Like I say, you need to be able to do these by hand. Yes, we'll use the calculator a lot, but you cannot be a crutch. There are often times when you will not be allowed to have a calculator to do these things. So you need to make sure you know what you're doing by hand so that you can check what your calculator is giving you. So let's try an example. We have this polynomial, x to the fourth plus 2x cubed minus 11x squared minus 6x plus 24. So the first step is find the zeros. Well, we need first our possible rational roots. So let's think about that. Well, this is 1, so that means we're just going to be dealing with all of the factors of 24. So we've got plus and minus 1, plus and minus 2, 3, 4, 6, 8, 12, and 24. So those are all our possible rational roots. So we're going to use synthetic division to try to figure out which one works. So we're going to start with 2. And we put our coefficients out. So we bring the first one down, multiply, add, multiply, add, multiply, add, multiply, add, and we end up with our 0 remainder. So that means that we're good with that. So far we know that this factors down to x minus 2 times, and this is x cubed plus 4x squared minus 3x minus 12 is our next place, but we need to factor that down further because we got to get it all the way down to the linear term so that we can, or at least to the quadratic, so that we can find our zeros. So we're going to try -4 and see if that works for this one. So we bring our term down, -4, add, multiply, and add, multiply, add, and we have our 0 remainder. So this means we have x minus -4, which is x plus 4. And then here we have x squared minus 3. Now, this doesn't factor into even integers, so we'll leave it like that for now. So for our zeros, what that means is we set each of these equal to 0 and solve. So we get x equals 2 and x equals -4 and x equals plus or minus. Don't forget, you have to have both the plus and the minus when you have these radicals. Square root of 3. Now when you're graphing, you're going to want to go ahead and get a decimal approximation for that, because it's kind of hard to picture where square root of 3 is unless we have a picture here. So we have the point 2, 0, the point -4, 0, the point square root, or well, let's put it in decimals. The point 1.7321, 0, and -1.7321, 0. Alright, so we've got all real zeros in this case. Remember, whatever the degree is, that's how many zeros you're going to have. And in this case, they are all real, so that works out nicely for us. When we look at the tails, well, this is an even degree, so they're either both going to be up or both down. We look at our leading coefficient here. It's 1, so it's positive, which means the tails are going to be both up. We don't have We don't have all the terms the same, even or odd, so there's no symmetry to deal with. And then we want to find our y-intercept. That means x is 0. Well, when you plug in x equals 0, all those terms go away, and you see that it's just at 0, 24. So, what do we have? Well, we have, let's see here, all right, so let's plot these points. 2, 0, -4, 0, 1.730, so that's really close right there, and -1.730, and then 0, 24, and we know both tails are going to be up, so we're going to start up and come down and around, and then I'm going to come up here and hit, and then here, and end up with some tails up. And that gives us a sketch of our graph. Now, you have to be careful because you're not quite sure where these minimum points here, or if this is the maximum here. You've got to kind of look at that and pay attention. So the easier thing to do is to look at your calculator. So now I'll warn you, when I use the calculator on the computer, sometimes it freaks out, so we'll hopefully get it to work here. So we put in this graph. So put in for your y equals. Now a standard window is not going to help us here because we know we have to go up to at least 24. So let's put our window, and let's keep the -10 to 10 on the x scale, but for the y scale, let's go down to, let's go -50 to 50, and we'll keep it as a 10 step there, and then graph it. And there we go. And we have our graph. And so you see over here with our red lines that we didn't quite go low enough here. And this does look almost like it's bouncing. But you see on the graph here, if you don't pay attention to where your zeros are, you might look at this and think, oh, it just bounces off. No, it hits it at the same place, even though it's just very close together. So without zooming in, you wouldn't realize that it had two separate zeros. Now we've talked about how to find the zeros on the calculator, so you can do that. The one thing I want to show you is how to find this minimum here. We've talked about it, but I want to do it one more time, so we can get our range. Because we know the domain is all real numbers, but our range is obviously limited here because we start here and go up for our y values. So you hit second trace, which gives you the calculate, and then we want the minimum, so it's number 3, and then it's asking for our left bound, so we arrow over to the left. Make sure you get all the way over left of it, good, and hit enter. And then again with the right, make sure you get over plenty so that you're giving the calculator that you're sure you got the interval taken care of. And then for your guess, you just arrow down close to it and then hit enter. And it'll give you a minimum. And this y number here will tell you your range. So what this tells us is, we know our domain is all real numbers, but our range is y such that y is greater than or equal to -30.3442. Okay, remember these are our set brackets to tell that that's what our set is. So, graphing on the calculator, more likely what's going to happen, but you've got to be able to do it by hand as well. And you've got to be able to at least get a sketch. You've got to be able to at least know if your sketch is anywhere close, okay, or if your calculator is giving you something close. So here we got a sketch that gave us something close, so we knew what was going on, and then we checked it with the calculator. Now, make sure you know how to do it on the calculator and you know how to do this by hand. Make sure you're using them together so that you get an accurate graph. Get some notes on the book, reading the section so that you've got this down, and make sure you have some questions written down for class.